So I started exploring the Google Agent Development Toolkit, the new or agent orchestrator that has been recently released by Google. And like whenever I look at an agent orchestrator, the first thing that I wanted to explore is how that orchestrator is managing the state of the agents, how it is um, how it is designed, the shared persistent state, what services it allows me to manage that state, right? And when I looked at the session management of Google Agent Development Kit, I I was in awe. Like I always say, as an architect, whether it's a product architect or an application architect, we need to be like a painter. Like in a painting, each component in the painting has a specific place in that canvas. Uh, it increases the overall aesthetics of that canvas. The way the session management has been architected so far, what I have seen in this package was beautiful, right? And I'll go in this recording, I'll go deep into some of these things that I have found out by going into the package, right? The data structure, the thought process that went into the different uh, the classes and the variables and the behaviors of the session that has been put into that class. uh, Google has put a lot of good thought in it. In fact, I have not seen that much of detail in the Landgraph state data structure, right? But before we delve deep into the session um, management in the code, in the Google Agent Development code, let's go through some theory, right? So in the ADK session management, the key components are, what is session? The session is one of the um, agent development kit object which helps to track and manage conversation threads, right? Why it is required? So, for example, let's say I am having a conversation with an agent, and as part of the conversation, at one point of time, the agent needs to pause because it needs to take a human input before it can resume, right? So at that time, whatever conversation has happened until that time, I can checkpoint it or I can persist that state using a session thread. And when I get the human comment, I can resume from that thread, right? That is one utility of session management. The other utility is, as a human is conversing with the agent, the state of that conversation or every events of that conversation, if I can store that in a long term persistent store, I can use that as an episodic memory for the agent, right? Similar to how human uses episodic memory, right? For example, if somebody asks me, uh, what was the weather when your wedding happened 20 years back, right? To retrieve that memory of that weather, right? A lot of I time travel to that particular episode, and to remember what the weather is. A lot of other things also come to my mind, right? Was there a sound of rain? Was lightning, right? Immediately, the memory comes back to me saying, "Oh, okay, it was raining heavily that day," right? The session management also, right? In this case, like if I am able to store each events of the current interaction as an episode in my memory, when I'm doing a similar activity, when the agent is doing a similar activity or a activity that relates to that episode, I can bring that episode back and give additional context to the agent so that its response is more precise, more accurate, right? That is in nutshell, I see the importance of session management. Now, in agent development kit, there are there is a session that tracks the individual conversation thread. It contains a chronological sequence of messages and action, right? One of the thing that in the application architecture, in the event-driven architecture earlier, like we used to have a pattern called event sourcing, right? If I keep a track of or the chronology of the events at any point of time, I can time travel and rebuild that event for auditing purpose, right? The session can act as a session memory by holding temporary state data during conversation or the episodic memory that I spoke about, right? The state, so there is a component, the state component, it enables to define a data structure. And that was a data structure I was talking about. It's a very rich data structure that uh, ADK session management has provided to hold information related to a specific conversation. And it provides an interface to manage the information with the state. That is a session services part of it, right? And it can be enabled to persist the information in different data stores. There are three different session services. We'll talk about it later. And the last component is the memory. So while the session memory, right, session state is for a particular conversation after the, so within that conversation, it um, helps the agents in that conversation to pass context, look at what the other agent has done, right? That is a session memory. And the long-term memory is where it can act as a cross-session long-term memory. If the agent has run multiple sessions, conversations earlier, can it leverage some of the information that was stored in previous conversations? Right? So it enables the agent to recall or search information or context from the past. As I was mentioning, to manage the session and memory, ADK provides a very rich session service interface and a memory service interface, right? We'll take in this recording, I'll take a deep dive into the session service and the session management part of it. Memory service, I am yet to go through it, right? Session and so in a nutshell, session and state focuses on the current conversation and managed by session service. Memory focuses on managing past and external information, the long-term information, similar to episodic memory, right? Let's go into the code and see how ADK handles this session services and session management, right? And this is where I was referring to the art part, right? That architecture needs to be like a painter, like an artist, right? And this is actually when I look at it, I was in awe. Like I was so I fell in love with this data structure, right? Okay, so let us create a session to understand its structure. Now, as I mentioned, think about the session object as a container that holds every information related to a specific chat thread. The session object, the way it is created is it has four distinct sections. A section that uniquely identifies the conversation, a section that stores the chronology of interactions, a section that can act as a scratch pad of the current conversation, and a section that tracks the timestamp of a event in this conversation thread, right? To understand the session architecture, let's create a in-memory session service, right? So I mentioned earlier, right? There is a session, right? The session data structure. To manage the data structure, I need a session service, right? So there are three types of session service in ADK. One of them is the in-memory session service. So I created an instance of the in-memory session service. If I go into this in-memory session service, you will see what interfaces it provides, right? It inherits from base session service. It provides an interface to create a session, right? It provides a like if I it provides interface to get the session based on an app name and user ID, right? It there are other inline things. I can list a session, right? I can delete a session if the conversation is done, right? And I can append events. I can append the interactions which becomes my episodic memory later on, right? And then yeah, the list events, right? These are the interfaces that the session service exposes to me to manage the session, right? So first thing that I did is using the session service, I created a session. So as I mentioned, one of the section is which uniquely identifies a conversation, which is the what is the app name, user ID, and like app name, user ID identifies the session. And then if I want to uh, store a state of the initial key value, right, I'll do this, right? This is the so when a conversation starts, right, before the conversation start, I'll create a session like this. This is where the data structure of the session has been created. Now, as the conversation is continuing, I'll keep on populating that data structure, right? So let's examine that part, right? So as I was mentioning, the core responsibility of the session service is like start a new conversation, like how the create session was done above. Resuming an existing conversation. This was the pause and the resume part that I was talking about. I'm yet to explore this part, but I'm pretty sure it works similar to how it works in LangGraph. Like in LangGraph, you can checkpoint a particular state and then resume that state from the checkpoint using a thread ID, right? Then there is a service through which you can save the state and the progress of the conversation through the append. So if you remember when I went to this in memory session service, there is an append. Where did that go? Append event, right? So this is uh, through that, right? I can save the state, append events for that particular conversation. When I say append events, that becomes my episodic memory, right? I'm reiterating this part because I wanted to uh, bring out how we sometimes bring in some of the brain architecture to design agentic architectures. Then there is a service to list the conversation and finally delete the conversation, right? This part I said like I'll explore later on, but let's explore the rest. Saving the state or the progress of the conversation, right? So let's say as part of the conversation, there is an event that happened, right? That there is a particular event of that conversation I want to store, right? ADK has provided a event data architecture also, and this is like beautifully thought through architecture. Data structure. So it has an invocation ID. I can give an invocation ID. I can say who authored that particular event, right? Um, so if the conversation is happening between Rajiv and agent, I can say, okay, this is the human who is Rajiv created it. Actions is a dictionary. Any actions that happens within the event. Right now, I have marked it empty. We can create event actions, store it here. Long running tool IDs, I am not very sure but what it is, but let's go to the event uh, data structure. So if you see invocation ID is the invocation ID of the event, author is the user or the name of the agent, the actions taken by the agent, the event actions I can store, um, set of IDs of the long running function. So agent client will know from this field about which function call is long running. Um, so it captures that event, but I'm still yet to um, understand what this information will help me to do, maybe some type of optimization later on I can do, right? Then the other beautiful thing is it can capture the branch of the event also. Like for example, agent one is a parent, agent two, right? The hierarchy of that agent system, I can store it. So branch is used when multiple sub agents should not see their peer agents conversion history, right? Conversation converse. So there are certain spelling mistake I have seen. So conversation history, right? For that, the branch of the event is used. Basically, what I understood here is if I store uh, that, okay, this is a conversation that happened between the human agent one and agent two, and I don't want agent three to look at that particular event. Uh, Through this, probably I can restrict it, right? Then the ID of the unique ID identifier of the event, right? As part of the invocation ID, that event, I can have uh, uh, as part of that invocation, I can store multiple events, right? So it uniquely identifies an event within that invocation, right? And the timestamp of that event, right? That's the data structure of event. So I said the invocation ID, author, action, I have kept it blank, long running tool ID is none, branch is none. This is the unique identification of this event, right? Next part comes as part of this event, what content I want to store. This is again the art, the beauty of this data structure comes into picture. And as I look more and more into this, I'm falling in love with this data architecture, right? The thought process, falling in love with the thought process that went through it, right? So if you see, user content is one of the types of content. It inherits the content data structure. Within that, if you see, the content has a part and a role. Role is whether it's a human or the model created, right? But what is part? If I go to part, it's a data type, it's a data structure that contains the media content, right? So as part of the conversation, there can be different types of message. It can be a thought message, it can be a code execution result, it can be the executable code, it can be the file data, it can be a function call, it can be a function response, it can be a inline data, or it can be a textual data, right? For every MIME type, for every type, so exactly one field within a part should be set represents a specific type of content being conveyed. Using multiple fields within the same part, instance is considered everywhere, right? So in a part, I can have one field, but the beauty of this data structure is now in the event, I can not only store a content, I can also define how a specific type of content can be stored, right? If it is a thought, I can say if the part is thought from the model. If it's a code execution, it will be the result of the executing the executable code. If it's an executable code, it is a code generated by the model, right? So this structure will later help me if I want to extract or parse a specific item from that content. It becomes easier for me, right? Now let me go back to the user content part. So user content is inherited, right, from the content part. And here in the user content, I can instantiate the user content like this, right? I can have a text like this, or as I mentioned, that there was in the part, right? I can also mention the URI of a file, right? I can also do bytes like this, right? And as I also mentioned, there is user content and there is model content, right? The model content also is similar, where I can store, uh, here the role will be model, right? but both of them follows the same content structure, right? So I created the event, I created a content object, and then I'm adding that content to the event. Through the append event now, I am storing that event into that state, right? That is my first event. Was part of the conversation. Let's say I want to store a second event, right? In the first event, I stored a file content type. In the second event, I'm storing a text content type, right? Content equal to user content, y is a sky blue ev2.content, and then I'm appending it, right? Next, I just put some code logic here to extract the events that I have stored and then um, displaying the events. Right? And then the other service that the session service provides is a list session. If I give the app name and the user ID name, I can retrieve that particular session. And finally, the delete session. So after delete session, I should not have any, the session should be all gone, right? So let me run this. Let me see if I have put the proper prints for everything. Okay. So the first thing that we'll see is when I create the session, we'll examine the session properties, right? And then, yeah, we'll go one by one so that it becomes very clear to understand this architecture. Right? Okay, so it created an ID. This is the session ID. This is the, I said, my app example user, right? This is the state, initial state, right? There are no events. I have not added any events so far. So there is no events and the last update time, right? After that, I created an event and two events, right? So if I look at those now here, print events event, right? The first event was this, right? Both are user content. I did not use a model content, right? First one, the part had a file data, right? This is how the file data is captured, right? I did not store anything else. It was only file data. This was the invocation ID. Author was Rajiv, right? Action, I did not store any action, but if I wanted, like if there are any actions, I could have stored in the event actions, right? And then this is the ID of that identifies the event, and this is the timestamp. The second event, the event is if is 02 and timestamp, and here I stored a text, right? This is the text I stored. Role is a user, and here also the name should be author should be Rajiv, right? Yeah. So this is what I stored as an event. If I so after that I list the session. This is where I list the session. So the session, I got the session ID, right? I know the app, so it is giving me the session, right? And then I deleted the session. We delete session. And then if I list the session again, the session is gone, right? So this is what I explored so far about the session data architecture or the data structure. I will explore more. And as I say, like this is, I'm really impressed by like how that session data structure is such a rich data structure, right? It is definitely going to be useful. I'll come up with more this type as I explore more. As I look into agent development kit, right? I'm starting to love this package. Thank you.